So, welcome to another session. Dear children, earlier you have seen the basic concepts of ray optics. Ray optics in another way is called as geometrical optics. So, why is it called geometrical optics? You should be knowing that light always travels in straight lines. And as it travels in straight lines, nature has always shown that it satisfies all the properties of plane geometry. To begin with, in your class 9 and 10, you could have come across reflection of light. So what is reflection of light? Bouncing back of light when it falls over smooth surfaces, be it plane or curved. This phenomenon we call it as reflection. So let us look at reflection in the case of mirrors, namely plane mirrors as well as curved mirrors. So today I will confine my discussion only to plane mirrors. So what is a plane mirror? We are all familiar with plane mirrors. So we have a reflecting surface like this, and this is the incident surface. Okay. So whenever light falls over a plane mirror, this you call it as the incident ray, right? And this is the normal. Light gets reflected like this. So this is the reflected ray. So the first law, what is the first law? The incident ray, the reflected ray, the normal. All three lie in the same plane. Furthermore, the angle of incidence, the angle made by the incident ray with the normal, and the angle of reflection, the angle made by the reflected ray with the normal, they are always equal. So angle I is equal to angle R. Now, using these two basic laws, we will see how different reflections take place or how we identify a particular image in case of plane mirrors. Okay? So, to begin with, let us say this is a plane mirror. Okay, this plane mirror, say we have an object placed in front of it. Say this is an object that we have placed. So a ray of light that is incident onto the plane mirror. Here you see that I am putting a ray exactly normal to the plane mirror, isn't it? This normal is reflected back in the same direction. Say we consider another ray of light incident like this. So draw a normal over there and that ray gets reflected. So if I produce these two rays backwards, then I would form a image over here like this. So if the object is a real object, the image is virtual. Further that we know that object distance is same as the image distance. Clear one? So, how do you basically make an image when reflection takes place? First, we need to draw a ray normal to the mirror. Right? That normal ray. For this ray, the angle of incidence is 0, so angle of reflection is also 0. So that's the reason why. This is the incident ray and the reflected ray going back in the same direction. And we are considering another ray. So a minimum of two rays is always necessary to form an image. Okay? Now, let us slightly modify the situation. Right? Say for example, I have a plane mirror like this and say I have the object as the letter B. So how would be the image? So at the same distance I need to draw the same line. Now this point here, say A, would be over here as A dash, and this point C would be over here as C dash. This central one, D, would be like this, D dash. So therefore, what I get is an image like this. So what are we observing? We observe that there is a left to right inversion in the image. So whenever we see ourselves in the mirror, there is always a left to right inversion. Okay, you have to note that there is only left to right inversion, but there is no vertical inversion. There is a lateral inversion, but no vertical inversion. Now, let us look at another situation. So in these two cases, the mirror was standing like this. Now the question is, what would happen if the mirror is at an angle like this? So instead of being vertical, now here the mirror has been placed at an angle, say theta to the horizontal. And say I have a point object over here, say O. This is the point object. Where would be the image? So now again, what did I tell you? Draw a ray normal to the mirror. So that's a ray normal to the mirror. So that ray would again be reflected back in the same direction. Take some other ray. Okay. So again, draw a normal over there. This is the reflected ray such that the angle of incidence and the angle of reflection are both equal. So produce the ray backwards, produce this ray backwards, so therefore the image would be over here. Normally students would think that the image would be over here as I dash, as in this case, which is wrong. So how to identify the image? To identify the image, we have to always consider one ray which is falling normally onto the plane. Okay? Now, I'll give you an assignment over here. Say for example, I have a plane mirror like this. Okay? Say the angle made here is 30 degrees. And say I have an object over here. Right? And this object is say at a distance 8 centimeters. Okay? Where is the image? Or what is the image distance? So, as I told you, what we have to do? First, draw a normal to this mirror, right? And then this ray would be reflected back in the same direction, and then consider some other ray, and then work out the mathematics that is there. Okay? Now, let us look at another very important issue. Say I have a plane mirror, right? This is a plane mirror. Say a ray of light is incident over it, like this. What would happen if I rotate the mirror by an angle theta? Okay? So if the mirror is rotated by an angle theta, always remember that the reflected ray will always rotate by an angle 2 theta. Okay? With simple mathematics, using your laws of geometry, you can prove this. You prove this. In case you have a difficulty, you can again post that back to me. Okay? Now, let's move on to another session, another variety of the same plane mirror, where we will be talking of combination of plane mirrors. Okay? Say I have a plane mirror, two plane mirrors for example. Say two plane mirrors are placed like this. The two plane mirrors here, as you can see, are at an angle theta. Okay? Now that they are at an angle theta, okay, what would I now do is, let us say a ray of light has been incident like this. Note that this ray of light is parallel to the first mirror, M1. Okay? It is parallel to the mirror M1. Say this is the mirror M2. Now after reflection from M2, like this, say the ray of light has been rendered parallel to the second mirror. So hope you are able to see, right? The first ray is parallel to the first mirror. After subsequent reflection, the emergent ray has come out parallel to the second mirror. What is the angle theta? That's the question. So if you have such a thing, here we simply apply the laws of geometry. Here M1 and the incident ray are both parallel, so this angle is theta over here. Isn't it? Likewise, if this angle is theta, this is also theta. The corresponding angles are equal. Okay? Now if I draw a normal over here, this is the angle of incidence, isn't it? So, because this is a normal and this is theta, this should be 90 minus theta. If this is 90 minus theta, then this is as well 90 minus theta, implying that this is as well theta. Clear? Apply the same logic over here, then this also becomes theta. So, here I have a triangle ABC in which all the angles are equal. This obviously means that this is an equilateral triangle. So, for an equilateral triangle, the total angle 3 theta is equal to 180 degrees. Isn't it? That's the total angle in a triangle. So, obviously, theta equals to 60 degrees. Clear? Let's look at a similar such a situation, but we will slightly change the conditions. Say I have incident ray like this. Again here, this ray is parallel to the first mirror M1. After reflection from the second mirror, right? Say it has been reflected in the same direction. That means here, after reflection, the ray is undergoing a return in its path. Right? So, now what is the angle theta in this case? So, applying the same logic of two parallel lines over a straight line, this angle is theta. So, if this is theta, then this is as well theta. Okay? Now, here the ray of light has been rendered backwards, it has bounced back. So, obviously, here the angle of incidence is 0, implying that this ray has been incident along. So, since the ray has been incident along the normal, it has also been reflected along the same normal. Implying for angle of incidence being 0, the angle of reflection is also 0. Obviously, this angle therefore is 90 degrees. So therefore, in this triangle ABC, you have two angles theta and one is 90 degrees. So what is the total angle in the triangle? 2 theta plus 90, that must be equal to 180 degrees. So 2 theta equal to 180 minus 90, or 2 theta equals to 90 degree, theta equals 45 degree. Is it clear? So, this is the methodology in which you have to solve problems in ray optics when it comes to the case of mirrors. Okay? Shall we extend the discussion? So, in continuation to the plane mirrors that we have done just now, we will do few more combination of mirrors. Let us say I have two plane mirrors placed mutually perpendicular to each other. So this is the way we have placed the mirrors at an angle of 90 degrees to each other. Let us say that we have a real object O over here. How many images are formed? So, by normal intuition, if I say this is the mirror M1, then this produces an image I1 over here. For the mirror M2, again at the same distance, an image I2 has been formed. Okay? So how many images do we see? For now, we see only 2 images. But then, let's extend the mirrors. Okay? So if I extend the mirror, then this virtual image of M1 acts as a virtual object for the extended mirror M2. So therefore, it would produce an image I3 over here. Okay? In a similar way, M1 extended backwards, I2 is a virtual object for M1 extended, and so therefore it again forms an image I3. So here you have to note that the image formed by 2 virtual objects in the extended part are overlapping at I3. So therefore, the total number of images that are formed is 3. And you should know another important thing, that we can construct a square including the object. I'll tell you why I say so. We know that the object distance is same as image distance, isn't it? So therefore, this total length is 2u, this length is also 2u, and this is also 2u. So therefore, the object and the 3 images form 4 corners of a square. Okay? Now there is a direct formula as well to calculate the number of images, that is 360 by theta minus 1. Okay? So if you put theta equals to 90 degrees, then 360 by 90 minus 1 is a 4 minus 1, that's a 3. Clear? Now let's extend the same question. See, there is no breadth of problems in physics. The more you think, the more ideas you generate, the more problems you will get. And it is more satisfying to solve more and more number of problems. Okay? Now you may ask, sir, why it should be 90 degrees? What if it is 60 degrees? Or what if it is 30 degrees? So, using the formula, theta is 60 degrees, then what happens? 6 minus 1 is a 5. So, 5 images are formed. So, if it is 30 degrees, the answer is obvious, right? But then, when we draw the figure for theta equals to 60 degrees, how do we represent or how do we locate the various images? So, say the angle here is 60 degrees now and the object is somewhere here. Okay? So, again, as we have constructed in the previous case, this is the image I1. For this, the image is I2 over here. Okay? What else? So, you may extend the mirrors like this, right? Then, this image I1 that I have over here would produce, I'll extend this a little bit, so that an I3 is formed over here. Okay? For this I3, you have a I4 over here. Okay? And then this I4, we have an I5 over here, diagonally opposite to this. So therefore, you see that if the angle is 60 degrees, then this forms a regular hexagon. Are you following? Okay. So, this is how, when there are multiple number of mirrors, we identify the images in this way. Right? Now, one very interesting case, in case of plane mirrors, is that what would happen if the 2 plane mirrors are parallel to each other? So, if I place 2 mirrors parallel to each other like this, then how many number of images are formed? When did you find such a situation? Did you ever encounter such a situation where there are 2 parallel mirrors? Obviously, yes. Whenever we are in a saloon, there is a mirror in front of us and there is a mirror exactly behind us. So there are 2 parallel mirrors. And how many images do we see? We find infinite number of images in case of 2 parallel mirrors. Okay? Now, Previously, there are many examinations where questions based on the number of images or distance between images have been asked. Okay, so today we will discuss one such question. Okay, we will discuss one such question where we will try to calculate the distance between the two images formed by two plane mirrors. Okay, so to start with, let us say I have